In the previous lesson, we have looked at the structure of an atom. And we mentioned that when you take an atom, it consists of 3 subatomic particles, which are protons, neutrons, and electrons. We studied that when we look at the structure of an atom, the protons and the neutrons are found in the nucleus, whilst the electrons move around the shells of an atom. In today's lesson, we'll be looking at electronic configuration, which will basically look at how these electrons are arranged on the shells of an atom. So by the end of the lesson, we expect that as a student, you should be able to examine the electronic configuration of an atom. Now, what is the electronic configuration? So when we talk about the electronic configuration, we are simply basically looking at the arrangement of electrons. So we are looking at the arrangement of electrons on the shells of an atom. So we are looking at how electrons are arranged on the shells of an atom. So electronic configuration refers to the arrangement of electrons on the shells of an atom. Now, for electrons to be arranged, there are certain rules that one must follow. First and foremost, you must realize that the position of an element is the same as the number of electrons the elements have. That's why you are supposed to learn the first 20 elements of it. So for example, hydrogen is element number 1. So therefore, hydrogen has only 1 electron. When we take sodium, for example, it is element number 11. So it will have 11 electrons. And then when we take calcium, it is element number 20. So it will have how many electrons? 20 electrons. Now, the arrangement of these electrons is not done anyhow. It is done by a general formula, which is 2n squared, where n is equal to the position of the shell. So the n refers to the position of the shell. So let's say for an instance, like, let's say this is the first shell, we have our second shell, and then we have our third shell. We number the one inside as 1, the second one as 2, the third one as 3. So how many electrons should be on the first shell, which is the 1? So we can put that one into the formula and get the answer. So when you put it into the formula, you are going to get 2 electrons. Because you have 2n, which is 1 squared. 1 squared is 1, multiplied by 2, which is 2. So it means that in the first shell, you can have 2 electrons. Now, when n is 2, meaning the second shell, when you put it into the formula, 2 squared is 4. 4 times 2 is 8. So it means that in the second shell, you can have 8 electrons. And then in the third shell, when you put 3 there, 3 squared is 9. Times 2 gives us 18. Now it means that for the elements, which is the 118 element, some of them can have more than 8 electrons. So it can have as many as 18 electrons. But then for the purposes of the first 20 elements, we have only 8 electrons maximum. Moving on. So this is how the electrons are arranged. The first shell takes 2 electrons, the second shell takes 8 electrons, and the third shell can take 8 electrons. Moving on. So let's take example like helium. We know helium is element number 2, right? So it means that when you are drawing the structure or the electronic configuration of helium, you will only have 1 shell and there will be 2 electrons arranged on it. Now, when you take an example like the magnesium, magnesium is element number 12. So if you want to draw the structure, the first shell will take 2 electrons. The second shell will take a maximum of the 8 electrons. 2 plus 8 gives us what? 10, and then it will be left with 2. So you put the remaining 2 on the last shell. So you can draw for other electrons. In our next lesson, we'll be moving on and we'll be looking at the periodic table, and then we'll look at how elements, which is the first 20 elements, are arranged in the periodic table. See you in the next lesson.